Hello, my 11th graders. So today we're going to be talking about right triangles and trig to satisfy this math concept. So I'm going to start off with the triangle right here. We should know from previous years that when we have an angle, our opposite side will be directly across and our hypotenuse will be directly across from our 90-degree. And our adjacent side will be between our 90-degree and our acute angle, okay? So now, to solve problems like these, we are going to use the Pythagorean theorem, but I'm going to convert it in some terms differently, okay? So a squared is going to become our adjacent, so capital A squared plus opposite, so b becomes opposite square, and c squared is our hypotenuse, h squared. We're also going to be using the famous SOHCAHTOA. So what does SOHCAHTOA stand for? Well, S stands for sine theta equals O over hypotenuse. And then, so this is so, and then ka is cosine theta equals adjacent over hypotenuse. And ta is tangent theta equals opposite over adjacent. Okay, moving on to our second section, an example. Here we are giving that our adjacent equals 3 and our opposite equals 4. And we need to find the hypotenuse. So we're going to use the Pythagorean theorem, where we know that our adjacent is 3. So 3 squared plus our opposite 4 squared equals hypotenuse squared. This is 9 plus 16 equals hypotenuse square. 9 plus 16 is 25 equals hypotenuse square. Square both sides, and you'll get that our hypotenuse equals to 5. Now, using SOHCAHTOA, we're going to solve our question, which was to find sine, cosine, and tangent. So we know that sine is opposite over hypotenuse, so it's going to be 4 over 5. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And these will be your answers, so please box them. Now I want you to try this problem, and we're going to find again sine, cosine, and tangent. Hopefully you have set up your problem, and we're going to again use the Pythagorean theorem, where we don't know what a squared is, since that's what we need to find our adjacent side, but we know that our opposite is 5, so we're going to square it equals hypotenuse squared, which is 10. So then a squared plus 25 equals 100. Subtract 25 from both sides. We will get that a squared equals 75 square root. And our adjacent will be 5 over the square root of 3. Now, using SOHCAHTOA, we know that our opposite, that sine is opposite over hypotenuse 10. This will simple out to 1/2. Cosine is adjacent 5 cubed over our hypotenuse. This will equal to square root of 3 over 2. And tangent will be opposite over adjacent. Our 5's cancel out, and this will be 1 over square root of 3. So these are your answers. So we're going to box. Now for an extension problem. I want you to think how you will solve this. Like, what do you notice that is different from our previous problems that we just did? Also, bonus, what would you have to do, or how would you get our remaining trig identities, such as cosecant, secant, and cotangent? We'll discuss in class tomorrow, and thank you for listening.